Okay, so we're still looking for the loss function, and we just defined the optimization problem for the discriminator. And for the discriminator, we want to maximize this function. Alright? So now we're going to look at the generator and see what his optimization problem is. And remember, the goal for him is to fool the discriminator. Fooling the discriminator means that the probability of this argument dg of z should be 1. Yeah? If this is 1, then the discriminator will be fooled. Now, in previous session, we saw that dg of z with respect to minus 1 minus the log of dg of z looks like this. So now we're actually trying to end up in 1, so we go to minus infinity. Right? So we're gonna minimize this piece of the function. This piece of the function does not apply for the generator. There's only one component. But since we're going to optimize and take derivatives, we're gonna put it there anyway. Because when we take the derivatives, it will be set to 0. But at least there will be a lot of symmetry between those two functions. Alright, so the loss function for the GAN, I can combine these two, we'll take first the maximum over the discriminator with parameters theta. And then we take this log of d of x plus the log of 1 minus dg of z. Alright? And then we close. And after that, so this is theta. And after that, we take the minimum for the generator that is parametrized by phi. Alright? So this is actually the loss function for GANs. And there's basically two contradictory objectives for this term. Discriminator starts to maximize, and generator has the ambition to minimize. So this is why this is called a two-player game with each opposite objectives, so an adversarial game. And a min-max problem is a term quite well known in the game theory, and I will give a short intermezzo on game theory to get you familiar with the terms.